All right, welcome to the Excel tutorial. Today we have two data sets, and our job is to try to find where those two data sets intersect. So the first thing that we have to do is download our data. So you can click here to download it. I've already done that to save some time. The data you'll notice on the course website is comma separated, so it's just one piece of data, comma, and another piece. So what you've just opened up looks like it's in Excel, and it is, but Excel is still thinking that this is a comma separated variable file. So the first thing that I'm going to do is save it as a workbook. Saving it as a workbook instead of a CSV file will get us all the functionality that we would normally get out of an Excel spreadsheet. So just change this to workbook and save. All right, if your data doesn't look like this, there's two things you can do. One, all of your data might just be in one cell, like it looked like in the course website. So it might just be all of this in one cell. If that's the case, you can select all of your data by doing Control-Shift down, then go to the Data tab and do Text to Columns, and then follow the instructions. If you opened a blank Excel spreadsheet and you want to import your data from some other data set, you can go to, again, the Data tab, then Get External Data, and then From Text. A CSV file is still a text file. So then you could open up this, and again you'll follow the same instructions. Just make sure that you click comma as a delimiter. That's just telling Excel what symbol is used between pieces of data. Then when you click next and finish, you'll get back to where this is. Newer versions of Excel just do it all by itself. All right, so we have a bunch of data. Before we create a plot, make sure that your cursor or selected square is off in the middle of nowhere. One time I had a data set that was 1,000 points by 1,000 data sets, and Excel is going to try to create whatever plot it thinks you have based on where your current cell is. So before you create a cell, click in the middle of nowhere. So then in the Insert tab, we can go to this little box that is a scatter and click the very first one. That'll get us a blank plot. So to put plots on that, we can just right click and go to Select Data. And then to add data sets, this is the same place you're going to go if you want to add any data sets to this plot. So we're going to click Add. The first one we're going to add is the supply curve. Note that whatever you put in the series name is going to go in the legend, so you might want to think about that before you're typing stuff in. The X value of this plot was going to be quantity. So to get quantity, I'm going to click the first one, Control-Shift down, which will get me the whole column. Then for the Y values, make sure you always delete what's in there, otherwise Excel is going to throw up some errors. And throwing up, never good. All right, so then we just click at the bottom, Control-Shift up, but I don't want the top cell. So to get rid of that top cell, I'm going to hold Shift down. Just Shift and the arrows lets you modify it by 1. Everything here looks good, so we press OK. And in the background, you can see it looks about right. So to get the demand curve, we're going to add another data set. So again, the series name I want to be demand. I'm going to do the same for the X values. And then for the Y values, I'm going to do the same procedure. Note that Excel cannot do equations in a plot. So I can't just plot y equals mx plus b like via an equation, because Excel needs discrete data. That'll be important later. All right, so we have a plot. The only thing we're missing is all the formatting to make this look good. So one way we can get us most of the way there is using quick layouts. You can find that just by clicking once on your plot, going to the Design tab, and then the second one is going to be Quick Layouts. I always go to the first one because it includes most of the things you need. There's just one major issue with this, in that if I wanted to know where on the x-axis was 120, I currently have no way to do that because I don't know where 100 and 200 are. So to get vertical tick marks or grid lines, you can just right click on the x-axis and go to add major grid lines, and then you're good. If we go back to the website, the x-axis of this was quantity, the y-axis was price. So you can just double click, or you can just type in here, I want this to be quantity, units, make sure you include units. If you're typing up here, you can just press enter and then it'll automatically update. The other way you can do it, after clicking once, instead of going up here, you can just keep clicking until you've selected something. This I want to be price. This is not dollars. All right, we're getting there. The other thing that we're going to do, because we're going to be putting this in Microsoft Word later, it's always going to have a caption. So if we have a caption, we shouldn't have a title. So you can just click once on the title and delete. It's important to note that we do have two data sets, so we can't delete the legend. The only other issue that one could see in this, perhaps, is that your x-axis is kind of getting covered up by your data. One way to change that is to click once on your y-axis and then go to your right where there's these little bars. And then under axis options, you can change where the horizontal axis crosses your vertical axis. In this case, I'm just going to put it at -10 because that's where my x-axis or my y-axis is. So now at least I can see my axes. If you were getting a little nitpicky, there's one other thing you could do. If you click once on one of your data sets, and make sure you just click once, you'll see a bunch of them selected. Then you can go to the paint can, and the issue I have with this is that you can't really see all the data because it's just so big and blobby. So if I change the size down to something small, it just looks better. We can go to the other one and do the exact same thing. What I'm doing here is there's something in professional plot making world called the data to ink ratio. And my goal is I'm just trying to make this ratio as high as possible. So to have the most data per ink means that I'm going to try to use the least amount of ink possible to represent my data. And then that's usually the key to making professional looking plots. All right, from this, double check. We have axes. These axes have units. We have a legend because we have multiple data sets. And then the x-axis goes out too far. We don't actually have data over there. So if I just click once on the x-axis, I can edit the maximum and minimum of the axes. And I would say this is good. All right, so the next step. If we want to find the intersection of these two data points, we're probably going to need to convert these into a line. So I'm just going to click once on the plot, Control C, and then click somewhere else, Control V. This is still a fully editable plot, so I can do anything down here that I did up there, but this saves me a lot of time when it comes to formatting axes and other stuff. So this is experimental data, so all experimental data should still be discrete data points. But if we want to fit these to find an intersection point, we need a trend line. So if you just right click on any one of the data sets, you can go to add trend line. So then it'll automatically add a linear trend line and add it to the legend. The only thing we need is we need the equation. I think every time in my personal experience, I've needed the equation. All right. Make sure you include the r² value. The r squared value is just how good of a fit do you have. Then I'm going to do the same thing with the other stuff. So again, right click, add trend line, display the equation and the r squared value, and move it down here. All right, bare minimum, this is a good plot, but we can do better. So if you want to do better, one way to do that is I can't see the trend lines. So if you click once on a data set, again, make sure a lot of points are selected. The reason I say that is if you click twice, you're going to be editing a single data point, and that's not very useful. Sometimes it is, but rarely. So if I click once on a data set, I can then go over here to the paint can, and the cool part is that I can increase the transparency. Right? I still want the data to be recognizable as being there, but I don't need it to be so pronounced because it's the trend line that's more important. So if I click once on the trend line and again go to the paint can, I can just change that to a solid line, and then boom, easy to see. So I'm going to repeat that with the orange data. So again, I'm going to click once on all the data, paint can, I'm affecting the markers, so I'll increase the transparency to, I don't know, 70 something. Good. Then click once on the trend line. You'll know you're on the trend line if you just have two data markers that either extent. Again, I'm going to go to the paint can. I'm changing the dash type from dash to solid. Sometimes it changes color. If it does, just go up here and change the color. All right, this is pretty much like something you'd see in a textbook. The only thing if you wanted to go a little further, the label for this trend line, if it could get lost as far as which one it is. So if you want to change the text, you can go up here just like in Microsoft Word and change the text to blue. That way, whatever happens to this plot in the future, I always know which equation goes with what. Like that. Note that if you ever have a legend that's overlapping your plot, sometimes the axes or the grid lines can get a little confusing or cover up your label. So if you want to change that, you can just click on the border of your legend and then fill it to be white. And then when it's filled white, you don't have that issue anymore. Just make sure that that white border is not covering up your data. But I'm going to put it over here. All right, so there we have a pretty sweet looking plot. Now, if we want to find where the intersection point is, we can do two things. One, we have the equations. We could just set them equal to each other and use some algebra. That's one way to do it. The other way to do it is to just zoom in on this point until you've zoomed in close enough that you can estimate what it is. So, again, I'm going to copy and paste this plot so I don't have to reformat anything. Then, to find the intersection, I just have to zoom in on this plot. So, I know the intersection point is somewhere between 100 and 200 on the quantity axis. So 100 and 200. And then I click once, or you could do twice too, on the y-axis, and again I'm under the bars, axis options, and I know that's somewhere between positive $10 and 15. And now I can estimate that pretty well. If you wanted to estimate that further, you could just continue zooming in until you have as many significant digits as you want. At this point, I would say that the intersection price is going to be about $12.50. The other part of the problem that it asked was, say that the supply had to increase its price by $2. So if we had to increase the price by $2, we would be shifting the blue curve up $2. Now, if you remember all the way back to 7th or 8th grade, to shift a curve, we can remember that to shift it upwards, all we do is add c, and then all the y values would increase. To shift it to the right, we will remember that it is x minus c. So this will shift something in the x positive direction, and this is the y positive direction. So I know that in this problem it was a tax of $2. So I'm going to put just tax as a label and 2. This way I can change it later. So here we would put the label of taxed price. And then all I want to do is add $2 to whatever's in the supply column. So to add an equation, I'm just going to put equals, and then I'm going to click on the cell that I want to add $2 to, and then plus 2. Then press enter. You could copy and paste this anywhere you want, and that would work. The only issue that we have is that if you click on the cell, the supply price is moving as we would want it to, but so is the tax. So the way we get around that is in the original equation, you can just put dollar signs in front of anything you don't want to move. So as I'm copying this downward, the row is going to keep incrementing. So if I put a dollar sign in front of the 6, that's all I would really need. But usually just put a dollar sign in front of the letter and the number, and that's going to probably be good for 95% of your use cases. Then I press enter. And again, you could copy and paste this downwards. The other way to do that is there's a little filled in box in the lower right corner. You could click and drag. If you are lazy like me, or just press for time, just double click and it will propagate that equation until the column next to it is finished. If you don't know where that is, right here. If you're ever going about in Excel, the easy way to get somewhere quickly is just Control up and you'll go to wherever it stops. Control left, you'll go to wherever your data is. Control right is, you can see, you just go to the extents of whatever. All right, so again, remember that Excel can't plot equations, so we wanted to add $2 to all of this. This is good, except it's not the right thing. Oops. What this did is this added $2 to all of our discrete data, which is fine, but then we'd have to fit the curve again, and that's just a mess. So to add $2, we're going to do y equals mx, we're moving it up, plus b plus c. So we'll, up here, do an equation that is this equation. So m is 0.0846 times x. X on this plot is quantity. So we'll go over here to quantity, and we're shifting it nowhere. Then we're moving it up by $2. But first we have to add this, so 0.0543, and then plus 2. And again, you can press F4, or just press dollar signs. And this will give us the equation for a line that's been shifted up 2. So if we wanted to plot this and see what it looks like, we could, again, copy and paste this plot. Right click because we want to add new data. And here, this data set is going to be the taxed supply. The x values, again, are going to be the same thing as always. So quantity, Control Shift down. For the y values, it's going to be the rightmost column, Control Shift up and Shift down. And voila. All right, so this looks good, but this is, you'd get a few points off. When we added this new data, we knew exactly the equation for it. So we knew the data at every data point. Therefore, where it has discrete data, as noted by the dot here, we need to change that to be a solid line. So to change that, we're just going to click once, go over to the paint can. We want this to be a solid line. I prefer green. And then we need to get rid of the markers. So if you go to marker, marker options, none. And voila. We don't really care about the equation unless you are doing that to find the intersection. So if we wanted to find the new intersection, we could Control C, Control V, and then again change the limits. So again, this is going to be somewhere between 100 and 200. And then on the y-axis, it looks somewhere between 10 and 15 once again. And there we go. So our price has changed. So because we had a tax applied to us of $2, our new optimal is interestingly not $2 above, but rather it is about 75 cents above, which is kind of cool. And this completes all the tasks required for Excel. If we now wanted to get this into Word in a professional manner, let me show you. So I'll open up Microsoft Word, blank document. All right, first things first, names. There are some basic formatting that you'll need to do. In this course, almost everything's going to be group work, so you could just keep going with this and just keep adding all of your group members. After that, we need a date. The date today is February something. And after that, we could have a section. So this is, I'll just do section 1 for now. After that, we need a title. So this document is going to be Excel tutorial, supply and demand data. All right, so if you get this far, you've avoided probably 5 to 7 points being taken off. The easiest way to format this, I find, is to go to the website, and it has some discrete tasks that it wanted you to do. So the first one, there's nothing to respond to in Word, so I'm just going to pretend that doesn't exist. The second one has something I could respond to. So I'm just going to copy and paste the entire task, and then after you paste it, you can go to the right and keep text only. That way it at least matches the formatting. All right, so this way I know that whatever I do, I can keep referring back to what was the task that I'm supposed to be responding to. So it says plot the supply and demand data. So first of all, before this plot arrives, I at least need to tell the reader what this is. It's supply and demand, but we can be a little bit more informative. So what we can do is say figure 1 presents the supply and demand data for a new meal option at Memorial Union. The supply data is represented by scattered blue points, and demand is orange. All right, so here we've at least said that there's a figure coming up. The figure is called figure 1, and we've told the reader what to expect. After that, we can go back to Excel and then copy and paste this first plot. There are a couple ways to do that. I'm just going to do Control C, that's standard. Once we get to Word, you can either do Control V and just paste it. The issue with this is, and maybe this is a perk, is you can still edit things. So if you wanted this to change, you could do that, just double click. I find that usually to be a hassle because I've usually done all the formatting. I don't want to change it. So I still have it Control C. So if I go up to paste, there's an arrow underneath it, and then you can go to paste special. And enhanced meta file is always going to be the one that makes it into a vectorized image. So whatever you do to this, it's like a PDF. So it's still going to be pretty no matter what size it is. So I'm just going to throw that in the middle of the page, make it big enough so that I can at least see what's on it. Then I've called it figure 1, so I should probably give it the name figure 1. You can just right click on your image or your figure and go to insert caption. In the insert caption, it's going to prepend with whatever your caption should be according to the increment of what figures were before it. And keep in mind, your caption is going to be read by somebody just casually picking up your document, seeing a pretty picture, and wanting to know what it is. So it's not going to be the reader that needs to read this. So it may seem redundant with what description came before it, and that's true, because it's for two different readers. So this is a supply and demand data for new meal at Memorial Union. Make sure that your caption says a little bit more than just price versus quantity, because somebody could already get that just by looking at their document. In this case, it's a figure, so it's a figure. If you ever do a table, you can just click table, and then it will start your caption with a table. And note that it will automatically put it above a table, because that's what it's supposed to do. So you do the same thing with tables. Don't use the one for equations, it's just a mess. All right, so I want it to be a figure, press OK, and it looks pretty. So before we have a description, then we have the actual plot. Next thing we have to do is say, what did I just give you? Yeah, I gave you a plot, but tell me something about it. So usually some ways you can go about this is to describe what about your plot looks correct. What about your plot would be useful for your reader to know? And then is there anything that stands out that shouldn't be there? Those are the types of things that you could typically analyze after a plot. So in this case, I would just say the supply data is linearly increasing from a value of $0 at 0 quantity to $35 at 400 quantity. The demand curve data is linear decreasing from a value of roughly $20 at 0 quantity to $0 at 400 quantity. You could probably give some amount of scatter if you knew roughly how much this is. So for instance, you could say the data is scattered at plus or minus, I don't know, $4 at a given quantity. The scatter is constant. I don't really see too much else that you could remark on this specific plot. So from here, you could just do the same exact thing everywhere else in the document. There's just one last thing I want to discuss. So if you had to do equations, one way you could do this is, you need to always introduce that an equation is coming. So in this course, a lot of things we'll be dealing with are cross-sectional areas. So you could say that the cross-sectional area, note this has nothing to do with supply and demand, the cross-sectional area of the tree was calculated via equation 1, where R represents the radius of the tree. Then we could insert an equation, so insert equation. Cool thing is Microsoft Word will automatically do Greek variables, so if you want pi, you can just do backspace pi, and voila. I think it's really cool. If you're ever doing superscripts, it's always just do space and it will make it look pretty. If you're ever wondering if you did it right, just press space and see if it formats it right. If not, you did it wrong. All right, so we've called this equation 1. We have to somehow include the name. So the thing I always do is this is going to be equation 1. Note that this parentheses 1 has to match the parentheses 1 up here. Then to make it look professional, we always right adjust, arrow over, and tab the equation right back to the middle. And it looks pretty cool. So the most important things here are that we've introduced what the equation is. The other thing you need to really make sure you do is that all the variables need to be previously defined somewhere. So for instance, you'll note the cross-sectional area I didn't define. So the easiest way to do that is here where it says the cross-sectional area. You could either just do parentheses A or A like so. I usually just do parentheses. So the cross-sectional area of the tree was given in equation 1 where R represents the radius of the tree. And you're done. Note, you only have to introduce variables once, so if you've already done this somewhere else, it's the reader's job to remember what that was. Granted, if you're doing a 300-page book, then you probably might want to either make a table of all your variables or refresh their memory every once in a while. All right, so if you were to just continue this with all of the tasks that were given in here, just note that every plot needs to have axis labels. They should probably be correct. You have your units. You'll note that our axes don't extend way beyond where our experimental data is. We have a legend because we have multiple data sets. We do not have a title because we always have a caption. That caption says something more than just repeating the axes. Every figure that we include will always have a description beforehand that mentions what figure we're talking about. And then afterwards, there's almost always some amount of analysis as to what looks good, what looks bad, or what else we might want to learn from other plots. The only thing left really is File, Save As, and then when you save it, just make sure that it's saved as a PDF, and then you're ready to go. That can then be uploaded to the website, and you should get fairly good credit. So thanks for watching if you've made it this far.